Hello friends. So the preliminary examination 2024 is very close, and we have been making this series of videos in this SISYPHUS series that we are doing in Minds of Aspirant. In that I'm solving the previous year question. So GS question papers I have solved, and CSAT also. I thought I will give you this basic understanding of what I thought was CSAT. Yes, it is a little difficult, but we will see the things which are manageable and are useful for clearing this exam. So I have been making some videos. In this, we'll see this particular topic of permutation and combination. The sum-based or the formula-based questions are a little tough, but the UPSC does not ask for such questions. We will see some of the questions from the, 2020, or these are the set of questions I have, 2020 to 23. The previous year questions related to this topic. This is how I wish you also prepare for CSAT. If some topic is there prevalent in this period, you start practicing, you start getting the understanding, and you can clear the cutoff. So without, I'll go with the first question. Look at this question. This or most of the question that comes from this section are not formula based. There are some difficult questions, I do agree, but look at a question like this. 5-letter word without, see, this is the point. Without any meaning or with meaning or without meaning, that is, you can have different words. The letters are, they say that it is Delhi. So, 5 letters are there. So you have to make five permutations. This is the point. This is the basic of this. And now they will give some conditions as to it has to start with D. So the question suggests is that it has to start with D and end with I. That is, in this 5 letters, D, E, L, H, I, in this 5 letters, they say this fact is that you have to have D as the first letter, I as the last letter. Then you have 3 spaces left. You have to have 3 permutations. This is the point, because this is kind of an arrangement. Arrangement means it is permutation. The arrangement of numbers in a digit is important. Arrangement of letters in a word is important. It is permutation. If you don't have to have this arrangement, then it goes to the combination. But the formula is very simple. Look at this NPR. That is, you choose N is the total number of things. R is the number that you choose. For example, here you have 5 letters from which you have to choose, 5P5. I am assuming, see, I am saying with the sense that it's not given with the condition of D and I. Then 5P5 will be the point. Then the formula is N factorial by N minus R factorial. This is the formula. Now, in this 5 letters, 2 has already gone. So only 3 is left. So 3P3. This is the formula. Look at this formula. If it is 5 letters, means you have to arrange 5 letters. But already 2 letters have arranged for ourselves. We have 3 more letters left. So you have to have 3P3, or else you can also go for, look at this, there are 5 letters, D, Delhi, correct? So in this 2 are gone, 3 are left. Okay. So this position can be filled out of the 3 letters which are left out. This can be filled with 2 letters which are left out. Now one more is left out and the answer is 6. So look at this answer. So I have chosen a sum for me to explain the concept of permutation. From this one question we lead, but basically if you see, you don't have to go for this formula. Rather, just understand this is not a combination question. Combination will be a different question. I'll show you some questions, but this is a permutation question which refers to the arrangement of words. One more question, you just check it here. Okay, next question is this. We'll go to this question. Here again, you see here, again, how many distinct 8-digit number? Okay, how many distinct, when they say distinct, that comes under the fact of permutation, right? Because you have to have different numbers and different arrangements will give different numbers, but can be formed by rearranging the digits of the number. Here, 8 digits are there, 1, 2, 3, 4, 5. So look at this 1, 2, 3, 4, 5, 6, 7, 8. So 8 digits are there such that the odd digits occupy odd positions, even digits occupy even position. So what they are talking about basically is that there are numbers like 1, 2, 3, 4, 1, 2, 3, 4. Okay. So there are 8 numbers are there. In this, what they suggest is that odd numbers occupy odd positions. Look at this. Odd numbers occupy odd positions, even number occupy even positions. So what we have to, how we have to arrange is that in this 4, you have to arrange these 4. It's very, very simple. In this 4, you have to arrange these 4, and that comes to this fact that, look at this, that comes to this fact that 4p4. Just check it. The formula is 4 factorial by 4 minus 4 factorial. 0 factorial is actually 1. So you have 4 factorial. That means 4 into 3 into 2 into 1. Look at this. Again, but the point is that even positions have to be occupied by even numbers, which is 2, 4, 6, 8. Here you have 2, 4, 4, 4, or you have to arrange them in such a way that in the even positions, they occupy a different kind of combination of numbers. So you will have, for example, look at this, you will have one more thing. This is the arrangement that you make for the odd positions. This is the arrangement you make again, because again 4 gaps are there, again 4p4. Okay, it's basically 4p4 by 4p4. Okay, but one small thing is that here you look at it, 2 numbers are the same. That is 2, 2, 3, 3, 4, 4. So what you have to do is that after this, divide it with how many ever numbers you have as a repetition. 1 factorial is repeated twice. 2 factorial is repeated twice. 3 factorial is repeated twice. That means 2 into 2 into 2. See, the point is that arrangements have to be made in the arrangements, because 1 here, see, 2 here, 2 here. You can put this 2 here, put this 2 here. It is not going to make any change in the number sequence. If the numbers are different, then it is considered as a new number. That's what this says. But when you have a combination of numbers as the same, you have to divide that. How many ever numbers are the same? Look at this 1, 1, 2, 2, 3, 3, 4, 4. So you have it here. So now you go for this. You just now the answer will be like 4 into 3 is 12 and 12 into 3 is 36. So this will be the answer. So this is how a combination based number or a combination based permutation based answer should be derived. And in the previous, I showed you the basic thing. Now you see, if it is having this repetition, you have to divide it by 2 whatever. So if there are 3 3s means 3 factorials. This kind of sum will come in let us assume that arrangement of words with repeated, repeated A or repeated B or something like that. There are questions like that. Now we'll go to the next question. Now you see here, this is one more question where it seems as, kind of, it can be done by the basic understanding. Look at this from A to or A to, this is also kind of the permutation combination thing. Now look at this, from A to B, you have three different routes. From A to B, you have three different routes. From B to C, you have four different routes. B to C, you have four different routes, and you have three different routes from A to C. This is the thing that they have given. But now what they are asking, how many how many different ways, how many different ways. It's kind of a combination question. How many different ways can be gotten from this. Can be directly given as a formula and you can write, but otherwise just check it. See, this can be one route. Okay, this can be one route. This can be the second route. This can be the third route. This can be the fourth route. That is, one can take here and then, repeat. And it can be done through again this route. Look at this. Again this way, this way, this way, and this way. Similar to the terms here also. That means that the person can take out of this three, he or she can take any of the three routes, and then it can take any of the four routes. So that's actually 12. But they are asking for, A to C. So from here to C, how many routes? How many possible routes? 12 plus, see here, 3. So this is actually 15. So answer is 15. So it's basically what kind of a route you take and the combination you take. That's what is giving the number 13 on, sorry, 12. So now you see here, the letters are arranged in such a way that there are exactly two letters. This is also, kind of this combination or permutation combination system. Now you see here, 5 letters are there. 5 letters are to be arranged. 5 letters, A, B, C, D, E. So 5 letters are there. So they are to be arranged in such a way. Look at this. Arrangement means the permutation thing. It's not the combination thing. But usually, as I say, in civil services, CSAT, mostly they don't think about formulas. Rather, they think about how you apply them. Now look at this. Now look at this point. In such a way that there are exactly two letters between A and E. So let us assume that, look at this scenario. They are saying that exactly 2 letters should be there between A and E. And if you see here, A and E can be this way also. So out of the 5 positions which are there, first you decide where the A and E should be. So it can be here. If it can be here, it can also be here. And the point now you should think for the arrangement. In the same as a Delhi question, first question that we discussed, Delhi was like, D should be here, I should be here. There were 3 positions in between. It's the similar kind of question with a little bit of twist. Now look at this A and E. Now how many letters are left out? Look at how many letters are left out. This is taken, this is taken. 3 more letters. Same way in the Delhi question that we discussed, 3 letters are left out. So you have to have 3 into 2 into 1. This is one possibility. Okay. The second possibility is again, here you can fill it with 3, here you can fill it with 2, here you can fill it with 1. So 2 possibilities exist where it is 6 plus 6, which is 12. Okay. But now the answer is not 12. Why? Because there are a few more possibilities. Third possibility is there. Look at this.
possibility, A and E can have like this also, E and E. So you can have an E and A here. Again, this will give rise to 3 into 2 into 1, 3 into 2 into 1. So this is 6 plus 6. So here 12, here 12. You have, what is the answer is that 24. This is the point that I have been trying to say. The A and E, the A and E can be arranged in such a way that you have this 4 varieties or 4 different permutations of arrangements of A and E can be there. In that, each word can be arranged in such a way that you get the answer. The first question I would want you to check again. It's the question that was asked in 2020. So this was a question that they asked in 2020, and you look at the question that has been asked here. This is, I think, 2023 or something.